if you're tuning in, welcome to the Workout Wednesday. So a reminder, Workout Wednesdays, I go live on Instagram, YouTube, Facebook, Twitch, everywhere possible, and answer any of your organic chemistry problems. Now, over the last week, there hasn't been a lot posted to me for problems to answer. So I'll wait to see whether there's any questions put into the chat. And if not, this might be quite a short session. And I'd also like to announce that here in Australia, it is school holidays next week, and I'll be spending some time with my family. And so Workout Wednesdays won't be happening for the next 2 weeks. So we'll be going back into it around later July. Okay, so just having a look at the chat here. We've got thumbs up from Philip KH. Thanks for joining us. We've got OChem Tutor. Good to see another organic chemist on the stream. We've got a wave from another student here. So thanks all for tuning in. If you've got any questions, put them into the chat and I'll do my best to answer them. But at the moment, I just wanted to have a bit of a rant, really. So I've been helping organic chemistry students for some time now. And I guess when I set up Organic Chemistry Explained, I knew what it's like for organic chemistry students, often suffering with bad quality professors. Basically, let's not beat around the bush. So it's not uncommon for students to be suffering with professors who don't care about their success. They aren't good teachers. They are not helpful. They're not available. When they are available, they're dismissive, they're rude, they're arrogant, things like that. So, I think this is a common situation in organic chemistry. So I was aware that many of the students I would be helping with Organic Chemistry Explained would be dealing with a lack of support from their professor and dealing with the difficulties they're having in adapting to the subject, which some students find difficult to adapt to. Now, earlier today, I was talking to a student that I'm helping with organic chemistry, and I was just shocked at what they said. They said that previously in an OChem subject, they'd gone to their professor for help, and when they didn't immediately get the get to the answer, or it didn't immediately understand the concepts, their professor said that they were stupid. They were stupid for not understanding organic chemistry. And I'm absolutely shocked at that. And I think that's just outrageous, and it's unacceptable for your professor to talk to you that way. That is completely unacceptable. And I think you have every right, if you wanted to, you could take that to a higher level. And I think that's grounds for disciplinary action against that professor, because I really do not think that's acceptable for professors to be telling their students they're stupid when they don't get a concept. And really, I'm a little bit shocked by that. And I hope that you're not suffering through that kind of situation in your studies. But if you are suffering in any way with a lack of support in organic chemistry, if you're having problems understanding the subject and you're not getting the support that you need from your professor, then please reach out to me and let me know how I can help. So Organic Chemistry Explained, I started this account so that I could help as many students as possible with organic chemistry. So that's the end of my rant. Please, if you're struggling with organic chemistry, it's not you. It's just a matter of getting to the stage where you've taken on board the right approaches to the subject. So organic chemistry is quite different to many other subjects you may have studied in the past in the terms of the way you need to approach it. And one of the most important things is to tackle as many practice problems as possible. So I'm working hard to develop sets of practice problems to help you with that. So I'm just looking at the chat here. So we've got OChem Tutor says, unfortunately, some professors are very short-tempered and are irritated by the fact that they have to teach, not only do the research. I certainly agree. And I understand the reasons why many professors feel short on time. And, to be honest, the university and college system is not helping many of these professors in terms of the workloads and things like that. And so I do understand the pressures that many of these professors have been under, and certainly I felt those pressures when I was working in academia. But certainly if you're faced with a professor who's rude to you, who is not speaking to you in a civil manner, that's unacceptable, and I believe that you should not accept that, and if needs be, then take it to a higher level. So looking at the chat, we've got berm spots, importance of maintaining double bond structure alongside and up carboxylic. So I'm not quite sure what that means. So importance of maintaining double bond structure alongside an up carboxyl. I'm not sure about that one. If you want to sort of reword that question in the chat, I'll have a go at it, but I'm not quite sure what you're getting at there. That is one of the, I guess, difficulties of doing a live around organic chemistry, because organic chemistry is so visual. If you're able to post the question ahead of these Workout Wednesdays by sending me a picture of some type, then I'm perfectly happy to go ahead and answer those questions during the live session. But if you want to expand on that question, then let me know. We've got Meow Purper. That's an interesting username. I had an issue with this question on my homework today. Draw the isomeric alkenes that would give you 3-hexanol as the only major product of hydroboration, followed by treatment with alkaline H2O2. Okay, that sounds like something we can dive into. So I'll move my picture out of the way here for those of you tuning in on Instagram. And we'll dive in. So we're talking about hydroboration with that question, and we want to get to the isomeric. No, we want to go from the isomeric alkenes that would give you 3-hexanol. So let's start with drawing the structure of 3-hexanol first. So when you're drawing organic structures, one of the most common mistakes is that students will make is drawing too many or too few carbon atoms. And so I like to go through a little ritual when you're first starting drawing bond line structures. Say pen down 1, that's your first carbon, and then draw your line 2. Oops, I've got the wrong pen here. Sorry about that. I'll just change. So pen down 1, and then move it 2, 3, 4, 5, 6. Okay, and then I think it's really important with organic chemistry to run checks and balances. So have we made a mistake by, just, it's very easy to make mistakes. And so it's good to double check things by, I always like to number. So 1, 2, 3, 4, 5, 6. And I would recommend you do that for pretty much any sort of organic chemistry problem, is number your skeleton, your carbon skeleton, to make sure you don't leave off any carbons or add any extra ones in as you go. Okay, now what was it? It was 3-hexanol, wasn't it? So at the 3 position, we should have an OH group. So to get that from a hydroboration oxidation sequence, we need to have added, so just recapping what hydroboration is, we're going to have a double bond within the molecule, like this. And it could be a trans or a cis double bond, doesn't matter in this case. And just drawing in a different color here, we're going to add a hydrogen on one side, and we're going to add a boron, but then the boron gets oxidized to an oxygen, so you overall add a hydrogen to one side of the double bond and an OH to the other. So, and then that can add either of one of 2 ways around. So we can have it like that, or if we imagine sort of holding that alkene still in space, we can have added the OH and the hydrogen the other way around. So the OH could have come in here and the hydrogen there like that. Okay, so taking that through to this product 3-hexanol, the 2 isomeric alkenes you could start with are where we have the oxygen added to the 3 position. So the other end of the double bond must have had the hydrogen added to it. So it must have been added either here, or it must have been added here. So either at the 2 or the 4 position. And so the double bond must have come from either between the 2 and the 3 carbons, or between the 3 and the 4 carbons. So that alcohol must have come from, let me just draw it down here. It must have come, oops, I'll draw this in black just to be consistent. So it must have come from a double bond being here, okay, like that. So that would be 2-hexene, or it must have come from, let me just do this over here, 3-hexene. Okay, so now when we get a functional group that can react in two different ways or multiple different ways with a reagent to give you different isomers like this, we call that regioselectivity, okay, or regioisomers. So when the OH gets added to this molecule, it can go in one of those two ways. Now, there's a little bit of a wrinkle in this, though, because if we now look at the second step of this, when we look at 2-hexene, we could have added the OH to this side or the hydrogen to this side. Okay, so if that happened, that would give us the wrong alcohol. That would give us the OH in that position there. And so let me just look at the wording in this question again. So let me just scroll back through the comments. So draw the isomers of alkenes that will give you 3-hexanol as the major product of hydroboration. So if we took 2-hexene, because the two ends of that double bond are fairly similar in terms of their steric, so you could say that one end is slightly less sterically hindered because it has a methyl group attached to it, whereas the other end has a propyl group attached. But in any case, we can get two different regioisomers out of that reaction. And so I would say that's not a good candidate for the molecule that would give us 3-hexanol. However, with 3-hexene, if we add the OH to this side and the hydrogen to this side, we get 3-hexanol. And if I do it in a different color now, if I add I'm going to scrub out that name of the compound there. If we add the hydrogen to this side and the OH to this side, because there's a symmetry, because that double bond's smack bang in the middle of that molecule, we're going to get 3-hexanol in either case, okay? Because we can start numbering 1, 2, 3 this way, or we could start numbering 1, 2, 3 that way from either end, okay? So it doesn't matter which way around it adds, because of the symmetry of the molecule, we're going to get 3-hexanol. So what does it mean by isomers? Well, don't forget, when you have a double bond like this, where each end of the double bond has two different substituents, we can have E or Z isomers, okay? And when we've got this sort of situation, we can also use the terminology cis and trans. That's not always the case. Sometimes cis and trans is not appropriate for an alkene, but in this case, we can use cis or trans. So we could use this one here, which is the, let me just go back to black. That is trans. Whoops, very messy writing today. Trans 3-hexene. Okay. Or we could be looking at the cis alkene like this. Okay, so that would be cis 3-hexene. And in either case, we will get 3-hexanol as the major product. Okay, so they're the two isomers that will give you that as the product in this reaction. Let me just go back over the comments. So let me know if you're still tuned in. Let me know whether that answers your question or not. Yeah, don't forget that when you do the hydroboration, we're actually doing it in two steps. The first step is going to be treatment with a borane, for example, borane as a complex with something like dimethyl sulfide. That's a very common reagent to use. And then the second step, because our initial product is a organoborane, our second step is going to be an oxidant such as hydrogen peroxide, and normally under basic conditions with sodium hydroxide. Okay, excellent. So meow you said you touched on my issue, so thank you very much. That's all right, no problem. That's what these Workout Wednesdays are for. So glad that I could help. Now, just scrolling back, are there any other questions? So we've got monoterpenoids, sesquiterpenoids, and their synergistic qualities with THC, precursor to CBG and cannabidiol. So I must admit, I'm not an expert about cannabinoids. I could tell you that terpenoids and sesquiterpenes and things like that are built up from isoprene units. So they're 5-carbon units. So a sesquiterpene is 3 5-carbon units. So you have a 15-carbon chain. So I can tell you about what terpenes are and what monoterpenes and so on are. But I'm no expert about THC and cannabinoids. So I'm going to leave that to your own private study. I'm sure that you can find lots of information online about cannabinoids and how they relate to terpenes and so on. And when you do find out that information, feel free to report back. What is your strategy to solve chemical formulas? So that's a bit general. So solving a chemical formula, I'm not quite sure what you mean by that one. I'll scroll down to give a bit of room here. So a chemical formula. So normally I would use the term molecular formula. So for example, if we have C10H12, that's I would call that a molecular formula. And as far as solving it, I'm not quite sure what you're sort of angling at there. If you want to know, how many double bonds there are within that molecule or rings, then we can use the fact that every time we remove a pair of hydrogens, we can replace that with an extra pi bond or with a ring system. So, for example, if we have C10H22, that fits the formula CnH2n plus 2. And that formula, CnH2n plus 2, is the formula for a non-cyclic saturated hydrocarbon. And so every time we remove a pair of protons, we know that we've added an extra pi bond or we've added a ring system. So that's something we can know about, from the molecular formula. But let me know if there's something else you'd like to know about chemical formulas. I think plant medicine is definitely interesting. Not really the topic that I wanted to concentrate for these Workout Wednesdays. And I know that certainly cannabinoids and cannabidiol are hot topics on social media and in terms of society in general at the moment. Okay, so I'm going to leave it there. I want to keep these Workout Wednesdays quite short. So just a reminder, if you tuned in a bit late or if you're watching the replay of this, Workout Wednesdays will be on hold for the next 2 weeks while I'm spending some time with my kids. So in Australia, it's the school holidays for the next 2 weeks. So just looking at the calendar, I think that means we'll be going back to Workout Wednesdays around mid-July. So anyway, I'll publicize it on social media. In the meantime, good luck with your studies. And if you do want any help with organic chemistry, feel free to go to my website, organicchemexplained.com, and go through the tutorials I have there. I also do private tutoring if you're interested in being tutored. And I look after a Facebook group called Organic Chemistry Help. So if you're a Facebook user, come find us on Facebook and on Organic Chemistry Help Facebook group. Okay, so enjoy the rest of your day and good luck with your organic chemistry studies. Bye for now.